I really like this table, table 12.13. It has a lot of information on it, so I'd like to break it down to maybe smaller pieces. Let's start with the top. So if I look at the top, what do we see? We see basically alkyne, and then we see alkene. So we have alkyne, alkene, and alkane. So Professor Klein is helping us. Just a short review how to go one from the other. So if I start with alkyne, I can add, remember hydrogen gas with the Linder catalyst, or you can use sodium, lithium, and ammonia. Two different reagents, not together, two different reagents, and that provides us with the alkene. Now, going from alkene back to an alkyne, remember what we did? We add bromine first, so that makes it a dibromo compound. We use a base, a very strong base, sodium amide. Now, sodium amide leaves the alkyne with a C minus if it's a terminal alkyne. So we need to add a little bit of water. So that water basically brings the alkyne back. Now, what are we going to do if you want to go from alkene to alkane? That was an easy one. Remember, we add hydrogen gas, we use different transition metal. This is not showing very well, but it's palladium. So palladium, platinum, or nickel help us to do this transition. So we talk about the top of the molecules. We talk about alkyne, alkene, alkane. Now let's talk about ketone, aldehydes, alcohol, and alkene halides. So if I have a ketone, I can add lithium aluminum hydride or sodium borohydride. Again, two different reagents, not together, two different reagents. I can convert that ketone aldehyde to an alcohol. Now, what should I do with the alcohol? I can take an alcohol, add chromic acid to it. So chromic acid or PCC, which is a derivative of chromic acid. I can go back from alcohol back to a ketone aldehyde. Now, how would I go from an alcohol to an alkene halides? A few things we learned. We learned that HBr is one. We can do that. Again, different reagents, not together. Or we can use phosphorus tribromide, so that's another one. Or we can use tausia chloride, sodium bromide. Again, three different reagents. Now, what if I want to go from alkyl halides back to an alcohol? We learned two reactions, SN2, SN1. In SN2, I can add sodium hydroxide. In SN1, which is a very weak nucleophile, I can add water. So then these two reagents, again separately, I can take the alkyl halides and convert it back to an alcohol. Okay, so now, as you can see, our little paper is getting crowded, but I try to leave those in the black or gray area, but we already talked. Let's go to start a new one. So if I want to go from a alkene, if I want to go from alkene all the way to an alcohol, what did I learn? I can add water and a little bit of acid, again different reagents. I can use hydroboration, and I can use mercury acetate. It's not very clear, but this is mercury acetate, and water, then water and sodium borohydride. So mercury acetate takes two different reagents. It takes mercury acetate water followed by sodium borohydride. Boron was another one we learned. We can add BH3 followed by hydrogen peroxide and sodium hydroxide. Again, different reagents. Now, how would I go from a alcohol? I want to go from an alcohol back to an alkene. If you remember what we did, we add water and sulfuric acid. Or we can use taucyl chloride. So taucyl chloride is a good reagent, makes the alcohol a good leaving group, followed by sodium ethoxide as a base to do elimination to form the alkene. So we talk about alcohol going to alkene, going from an alkene back to an alcohol. We need to practice. Without the practice, we're not going to remember all these reagents. We need to practice. Okay. Now let's go look at some of the remaining that we have on the side, on here and here. So if I want to start with again with the alkene, so let's say put a little yellow color on it. And this alkene, again, my paper got very busy. So I want to go back to alkyl halides. Going from alkene to an alkyl halides. This was what we learned in the alkene section. You can either add HBr or HBr and peroxide. And if you remember, one was Dr. M and one was not Dr. M. If that made a difference in the alkene. Now, what if I go from an alkyl halides to an alkene? Again, remember this was an elimination that we learned. So the part that we learned was using a base. We use a simple base like sodium methoxide and or a bulky base like potassium tertiary. And each of these made different products. Remember the alkene was a Zorytov product and Hoffman product. We have to go back and learn those again. Now, what if I want to go from an alkane, again, simple alkane, to an alkyl halides? Bromination was with the light, or NBS was the answer. So we used those two reagents differently to achieve this alkane to alkyl halides. Now the last on the left side is we have the alkyne. How would I go from an alkyne directly to aldehydes and ketones? If you remember the reagent we used, again separately, one set of reagent was sulfuric acid, mercury acetate, and water by itself, 3 of them. Or we could use a derivative of boron, like 9 ppm, and hydrogen peroxide. Again, many reagents. The best thing is to practice, maybe make index card, and learn this table. This table is very useful. Thank you.